Good morning, Doctor. This is Group 5 from Section 3, Foundation Engineering. So now I'll present our group project. My name is Tim. So our company is Hyok Consultancy Sdn Berhad, which is a geotechnical consultancy firm and established in 2024. We specialize in foundation design service and provide tailored foundation solutions such as shallow and deep foundation based on the soil assessment and engineering analysis. So these are our team member, Joita Tanrabe as a project director, Seraphim Muijawan as a geotechnical engineer, me, Limitian as a drawing manager, Christina Leong Seok Yin, structural engineer, and last is the Doris Kong Lian Jing, project manager. And now I will show you our mission and vision for the company. Our mission is to provide a reliable and efficient foundation design solution that ensure the safety and stability for every project. And the vision is to be a trusted leader in geotechnical consultancy, providing innovative and reliable foundation design solutions that support the success of construction projects across the various industries. So we provide several services. First, foundation design. Next, geotechnical site analysis, settlement analysis, and also the retaining structure design. In this project, we designed a shallow foundation for a 2.5-story bungalow. So there are several steps for us to complete it. First, we analyze the SI report to determine the soil parameters and profile. Then, we calculate and group the structural load for the foundation design. Next, we design the suitable foundation system with shallow foundation with necessary justification and identify a required soil improvement before construction. Then we produce a detailed foundation layout drawing following engineering standard and also using Prota software to meet the safety standard and perform reliably over lifespan. So the location for this project is at Lot 427, Section 4 under Bukit Mertajau, Daerah Tengah, Pulau Pinang, and below that is the coordinate of the location. So this location is situated within a developed urban area, providing accessibility and proximity to essential infrastructure. And now I will pass to my team member for the next part.
I'm Doris Kong Lian Jing with mention number 2FGO093. Today I will be presenting about soil profile analysis. In unconfined compression test, we can obtain the result of bulk density and dry density in megagram per meter cube. After multiplied by 9.81, we can obtain in unit kilonewton per meter cube. From bore log, we can obtain information such as soil type, changes with depth, groundwater level, and the measured SPT value. In order to calculate OCR value, pre-consolidated pressure obtained from one-dimensional consolidation test is divided by the density of the sand and the depth of the sample. In this calculation, groundwater effect is considered because the sample located below the groundwater table. OCR greater than 1 means the sample experienced greater stress in the past compared to their current experience. This equation is used to estimate standard penetration number. As China donut freeform machine is used, hammer efficiency is set at 60%. For borehole diameter 60 mm, correction for borehole diameter is set as 1. For standard sample, the sample correction is set as 1 as well. For rock length greater than 10 meter, correction for rock length is set as 1 meter. These three equations are used to calculate CN value, and the average CN value is obtained. The average CN value is multiplied by standard penetration number to obtain the corrected N value. These three equations are used to calculate angle of friction separately, and the average value is taken.
My name is Jovita Tan with batch number AF210088. I will talk about the design of foundation of this project. The structural loading of the project was calculated using Prota, structural modeling and analysis software. After getting the GK and QK of each column from Prota software, the total load is calculated and shown in the layout plan.
The type of foundation chosen for this project is pad footings, which is a shallow foundation. The reasons of choosing shallow foundation would be primarily because two-story bungalow have relatively light loads and sandy soil has good bearing capacity near the surface, which making it suitable for shallow foundations. Moreover, shallow foundation is chosen because deep water table at 7.1 meters can reduce the risk of waterlogging, which may weaken the soil. The deep water table also simplifies the design by eliminating groundwater effects. Furthermore, there are a few key design considerations which includes load distribution, soil type, and water table depth to ensure the stability and durability of the foundation.
To optimize the foundation design, column was split based on their loading range. Column T4 requires a customized footing due to the site constraint that it could not be designed with a square footing. To calculate the bearing capacity of the soil for our foundation design, we apply two methods. One is the Tajagi bearing capacity theory and another is the Hawk capacity equation. This is the bearing capacity result of each footing. All the thickness of foundation is 250 mm and the depth is 1.3 meter from ground level to bottom foundation. The maximum allowable load of the design footing size for 6 of the group are adequate to support the maximum column loading. For calculation of settlement, 3 different methods including Tajagi and Beck, Meyerhoff as well as Bullet and Dubish are used. These 3 methods are suitable for calculating settlement of foundation on sand based on standard penetration resistance. This is the summary result of settlement of each footing. Result from all 3 methods does not exceed the maximum allowable settlement. After calculated all the bearing capacity, settlement and reinforcement, the size and depth of footing is determined. The foundation band is then shown, and this is the detailing of each pad footing.
I'm Seraphim Wei Chao En with matrix number AF210118. I'll be presenting some of the soil improvement methods that can be used. Soil improvement is a technique for improving soil that is in poor condition or has been disturbed. For this project, soil improvement measures are needed to overcome several issues such as soil exhibiting excessive sediment, significant low water table, and low strength of soil. To overcome these issues, a variety of soil improvement techniques can be conducted such as dynamic compaction, installation of stone columns, grouting, and preloading. Dynamic compaction is one of the techniques where a heavy weight ranges from 5 to 40 tons is dropped from a height of 10 to 30 meters repeatedly in a predetermined pattern. This action generates powerful energy that penetrates the soil layers, causing the particles to densify and rearrange into a more stable structure. Other than enhancing density and load-bearing capacity of soil, this process also reduces total and differential settlements of structures. Another technique would be installing stone columns by digging holes in the ground using vibrofloat equipment, a long tube with jets at both top and bottom. The mass rotation of vibrofloat aids in soil extraction. After the excavation is complete, the hole is filled with stones or gravel. The size of stones can range from 6 to 40 mm. The diameter of a stone column ranges from 0.5 to 0.7 meter with distance between two neighboring columns of 1.5 to 3 meters. This method is ideal for improving soft or loose soils by reducing settlements and increasing load-bearing capacity. That's all from me. Thank you.
My name is Christina, matrix number AF210122, and I'll be explaining grouting as well as preloading as a ground improvement method for shallow foundations. Grouting is a technique of injecting ground into soil to compact, densify, and displaces the surrounding soil before setting and create a column of stabilized material. Now, grout is conveniently versatile in terms of soil improvement for new construction, fixes existing issues such as settlement, and improve performances for foundation and tunnels, as well as stabilizing slopes and fill voids. Now, there are 3 types of grouting, namely compaction, permeation, and jet grouting. Each method is unique to its own intentions, where compaction grouting involves a conventional injection of high-density cement grout directly into soil. Permeation grouting can be used in cohesive and non-cohesive soils, where it differs by injecting microfine grout to fill voids. And finally, jet grouting involves the injection of grout under high pressure to create soil cement columns. Diagrams on the right would illustrate the processes for each of these grouting types. Preloading involves the process of applying compressive load to soil layer to consolidate pre-construction. The main intention of this method being to reduce settlement of soil or rock layer underneath the weight of structure. It may as well prevent uneven settlement over time. Now, the duration and load of preloading process type influenced by type and thickness of soil or rock layer, weight and size of the structure, and the expected loads of a structure. However, the duration and load of preloading process can also be determined through lab testing, computer modeling, and field observation. Unfortunately, the duration could range from weeks to months and years depending on the soil or rock conditions. N60's value is determined by using equation proposed by Seed and Skempton, while the average value Cn is obtained using formula proposed by Liao and Whitman. Citadel, and Bazara. The corrected N value is calculated by multiplying M60 and the average value. The friction angle, however, is calculated using average values from equation by Peck, Schmertzman, Hatanaka, and Uchida. The proposed footing size for this project is acceptable as the calculated maximum allowable load using both the Zagi and Meyerhof method is larger than the structural load. Additionally, the calculated settlement for proposed footing for all the Zagi and Peck, Meyerhof, and Berlin and Burbridge method are less than 25 mm, which is allowable settlement for isolated foundation proposed by Terzaghi and Peck in 1946. The suggested ground improvement on site includes dynamic compaction, installment of stone columns, grouting, and preloading the area to improve conditions of soil. That's all. Thank you.